Morning, good afternoon, evening, and good late evening, guys. So this is the NETCONF working group meeting in lieu of the 107 face-to-face meeting. You guys are well aware of the note well by participating in this meeting. You agree to the IETF processes, which are outlined in a bunch of DCPs at the bottom of the slide. Make sure you're aware of them. Some administrative trivia. So for this meeting, we will be using the Etherpad as a virtual blue sheet. So use the Etherpad link at the bottom of the slide. It's there in the agenda also. Make sure you log in, put your name down at the bottom of the Etherpad with your company affiliation. And also for folks that want to contribute to the minutes, you can put your name against your color in the top right corner. That would be helpful. So this meeting is being recorded. Please mute your lines unless you're speaking. And you can indicate +Q or -Q to be added or removed from the queue. When asking a question, help us by stating your name. It's hard to keep track of who's speaking. On Jabber, I'll talk a little bit on the next slide. We are using Jabber, but it's unmonitored, although IETF does log the Jabber contents. For setup, you can use the link that is on the slide. I also sent it in the email yesterday. It can be used for any side discussions you want to have, but if you want to ask any questions, please ask on the WebEx or by indicating on the WebEx chat window, not the Jabber window. If for some reason you're not able to do that, you can ask. There isn't a Jabber scribe. You can ask someone who can post the question for you. Status of the chartered work group items. The NETCONF suite of drafts is still work in progress. There is a presentation today by Kent on it. The Yang push notification capabilities is past the second working group last call. The Yang push notification messages is work in progress. The authors agreed to defer it till we have an HTTPS draft. I'm told my audio is breaking up. Okay, I'll try this. Next break. The HTTPS notification draft is work in progress. And here is the agenda for the meeting. A presentation by the module version team on the impact on NETCONF and NETCONF protocol. Then we have either 001. Okay. That's as far as agenda. Any questions?
Pierre-François here, just to tell you that Thomas is presenting the multiple stream originators one. So I will only present the UDP-based publication one. Okay.
All right. If there are no other questions or comments, and I guess you are up first.
Okay, great, thank you. Slide number 1. And please let me know if my audio is coming through clearly.
Sure.
Okay. Thank you, everyone, for yet another opportunity to present this suite of drafts. This is the client server suite of drafts. Let me see, what are they? It's like nine separate drafts that we've been working on for quite some time here. Next slide, please. There were a number of updates that were made since 106, and typically I don't go over the updates. I just simply put the change logs on the screen. Next slide, please. So that everyone can be aware of all that has occurred. There were 2 separate updates to all the drafts since last time. And actually, if you could go to the previous slide just quickly. As you can see, the first 3 drafts, the cryptotypes, trust anchors, and key store, these 3 are the ones that we're trying to bring to last call as soon as possible. In the sense that they have their core drafts, we'd like to get them progress as quickly as possible. That said, I believe from a technical perspective, all the drafts are currently ready to be progressed. There's no more remaining issues except the ones that we're going to discuss on this call. Okay, can you 2 slides, please? 2 slides forward. This presentation's focus is really the 2 remaining open issues that we've been discussing for the last few sessions. The first is how to define a dictionary of algorithm identifiers. And the second is how can we enable a server to declare which algorithms it supports. And these are the only 2 remaining open issues. Next slide, please. But really the question is, what strategy should we be taking to solve these issues? And last time historically, I should say, we've been working on a solution whereby the cryptotypes draft defined a dictionary of all possible algorithm identifiers. And it was doing that, I think, initially using Yang identifiers, and then later Yang enumerations. And then most recently in the current update, still using enumerations, but now those enumerations are being programmatically generated using a script off of registries that IANA is maintaining. But nonetheless, that's the approach that's currently being taken. So that's number 1. Option number 1 is sort of continue with that approach, which is to define as much as possible, i.e. those algorithm identifiers in cryptotypes draft at that layer. Number 2 would be to actually break things out and try to move protocol-specific information into, for instance, the TLS client server draft and the SSH client server draft. And then 3 would be to actually give up, effectively fold on trying to support the ability for, to ask a server to generate a key, private key. So these 3 options are discussed in the next following slides. Next slide, please. Okay, so again, the current solution is that in the cryptotypes layer, there are 2 RPCs for generating symmetric key and asymmetric key. You can send a request to the server to have it generate that key. And actually that's defined in the cryptotypes module. And then separately in the key store module, it augments those RPCs with an additional parameter specifying yet another key in the key store that can be used to encrypt the resulting generated key that's returned to the client. So I say cryptotype layer, but it's augmented by the key store layer in that way. The new so there are now in the current cryptotypes draft a new IANA cryptographic primitives registry. So something that IANA would maintain, and actually more specifically, okay, actually that's bullet point number 4. So I'll wait till I get to that. And then so there's this registry, and so for instance, there's a registry for all the known asymmetric algorithms, and those would be, for instance, RSA or the various elliptical curves that can be used to generate asymmetric keys. And then likewise, various symmetric algorithms like AES or triple DES for symmetric keys. and then actually also a third registry for hashing algorithms, SHA-1, SHA-256, things like that. And so there's those three sub-registries in this cryptographic primitives registry. And then the idea is that there would be a script, which actually hasn't been, it's right now, it's in the appendix as a TBD, but there'd be a script written that would generate the Yang module from those registries. And then lastly, the idea is that there'd be a new column added to some other registries maintained by Anna. So for instance, in the TLS, there's a registry for various TLS parameters and another registry for various SSH parameters. And the idea is to augment those registries with an additional column to effectively map which cryptographic primitive is being used by those various TLS or SSH specific registry entries. And by doing this, the idea is that then the domain experts, the cryptographic folks, as and when they're updating the various TLS and SSH algorithms, they're being mindful to ensure that if there's any new cryptographic primitive that's being proposed, that then that cryptographic primitive registry would be updated in concert with their update, and then INO would generate the new Yang module, and it all happened automatically in the background. And then separately, so that's in the cryptographics layer, and then separately in the SSH and TLS layers, there was going to be also a TBD config false list for which specific algorithms a server implements. And I hear, so there's the universe, the dictionary of all possible algorithms that's in the cryptographic layer, and what does a particular server supports. And so this config false list would allow an ability for clients to discover the subset supported by a server. The benefits, the pros and cons. So the benefits of this approach is that first off, it's consistent with the view that algorithm primitives are protocol independent. So for instance, an RSA key doesn't itself, say whether or not it's used for TLS or SSH. It could, you have an RSA key, it can be used for any protocol that uses RSA. So in this sense, having the primitives, a dictionary of all possible primitives factored outside of how they're being used makes sense. That's consistent. The cons, though, is that it's inconsistent with existing protocol-oriented registries, or in array silos. And I say this really in the context of within the IETF. And I can't really speak for other standards bodies, but it definitely seems to be the case that most cryptography focuses on the protocols, and within the context of their focus on the protocols, they're thinking about the algorithms that those protocols are using, and they give those algorithms names, and so they kind of build up a solution that's around that protocol. And while it does use the same underlying primitives, they don't think of it in that way. So that's what I mean by that. And then secondly, it's a little bit it may be unclear if the same algorithm primitive name means the same thing to all protocols. And this is actually something I learned from in discussion with the Rich Sells, who's been he's actually a member of Sector, but also he's been on the list and someone that I bounce a lot of ideas off of, and he and I have had some discussion on it the last few weeks. Actually, Rich, are you on the call right now?
Yeah.
You're unmuted. Go ahead, I can hear you. You want to say anything about this?
So I don't know if you want to talk now or at the end. I mean,
well, yeah, now just in terms of how on point is this slide?
Sure. So it's basically good. There's one thing I want to two things. One, the cryptographic primitives is more, it's big. It's every curve is its own primitive, because you can't say I want to generate an ECC curve. You say I want to generate a brain pool key, whatever, or a NIST P521 curve. So it's a big set, you know, 100 plus. And then the comment about an RSA key doesn't care how it's being used. The protocol doesn't care, but there are out-of-band considerations that relate to security. You want to make sure that the same key isn't being used in multiple security protocols. That's probably out of scope of here, outside of we just sort of copy some of the security considerations. But there are, when I saw the RSA key, it occurred to me there are keys that have parameters associated with them. In particular, there's this thing called RSA PSS. And I forget what the PSS stands for, but it says, you know, you can only use it with this kind of hashing algorithm, or only use it for this kind of signature, you know, only generate a signature for it. So there are keys that have parameters that affect how they're used in the protocol. Although it's that statement about an RSA key doesn't care if it's used, that's accurate. It's just a little subtlety on there. I'm not sure if that's probably not worth going into, but there are corner cases here, which is, I think, why SecDear and stuff have been concerned about trying to maintain a universal registry. But we can discuss that later on. I know you have other slides.
Thanks, Rich. Next slide, please. Okay, so the second option is to, instead of trying to define a universal dictionary of all possible algorithm identifiers that are shared by all protocols, we instead factor it out, or those dictionaries out, into the various protocol layers. So in particular, in the cryptotypes layer, we would replace the algorithm type from what it's currently being an enumeration, really back to it being an identifier, and having identity ref to base identities, those base identities defined in the cryptotypes layer. But then the derived identities would only exist in the protocol specific layers. So then in the second bullet point there is, in the SSH and TLS layers, extend those base identities with protocol specific identities. Also define RPCs for generating the symmetric and asymmetric keys. And really those RPCs would be mimicking almost, parameter by parameter, the command line utilities that OpenSSL and OpenSSH provide. So in OpenSSL gen key, OpenSSL EC params, for creating RSA and I should say gen key, it was gen RSA is what I meant to say, for generating RSA and elliptical keys, and then OpenSSH is called SSH_keygen. So those command line parameters, we basically map them almost one-to-one into RPCs that would be living inside the SSH and TLS layers. And then lastly, define again that TBD config false list of the particular algorithm supported by the server, same as from the previous slide. So the pros and cons of this approach. Pros is that now we have protocol specific algorithm names. If you recall on the previous slide, there was a concern or that potentially, while the name is the same, it actually it's used in a different way, and there's unknown possible implications to that. And so this actually would resolve that particular problem, because now we're using the names that the actual protocol uses, and so that part, at least we wouldn't have to worry about doing a technical analysis as to whether or not there's a concern or not. Now we know, we would at least know there's no concern. It's been isolated. The cons would be that this approach is kind of inconsistent with the view that algorithm primitives are protocol independent. So it's just the reverse, the pro from the previous slide. So which the strength of the previous approach is sort of the weakness of this approach. I'm going to stop there on this slide and ask again if Rich has anything he would like to add. Unmute you.
Yeah, no, I think the con is huge, but no, this is all correct. Yeah.
Okay, good. Next slide, please. Okay, so option 3 is to really fold on this entire approach of trying to enable servers to generate keys. So kind of more specifically, this solution would be in the cryptotypes layer to eliminate the two generate key RPCs. So the generate asymmetric key and generate symmetric key RPCs, just get rid of those two RPCs entirely. and likewise eliminate the algorithm type field that's in the various key groupings. So just below that, you can see there's kind of an eye chart, but there's a grouping for a symmetric key and another grouping for an asymmetric key. And both of those groupings, the very first node is called algorithm. And you can see it's an identity ref to one of these. Actually, I'm sorry, it's not identity, it's an enumeration to one of these dictionaries that we're talking about. So we just remove it entirely. And surprisingly, I think that this would work because if you recall, we moved, what was it last time? We added this key format node. It's a separate node called key format. So we have for symmetric key, it's just called key format. And then for an asymmetric key pair, there's actually separately, there's a public key format and a private key format. And those key formats are, saying whether or not, is this, for instance, in TLS, in ASN.1, a subject public key info structure, or is it an RSA private key? These are actually the names. If you could see, I'm doing air quotes. These are the names of those structures. And inside of those structures, sometimes, actually most of the times, they actually have themselves an algorithm identifier. So it actually, everything continues to work. We can still, it could still be the case that clients can generate the keys externally using their local SSH or SSL libraries. And then, in doing so, they're constructing, these key formats, which would be consistent with this key format field, and then pass those resulting values into the server. And so the ability to, store keys in, for instance, key store would continue to be there. We could still support the ability of having hidden keys, as you can see on screen. That notion of a server being shipped from manufacturing with a pre-generated key, for instance, in its TPM, would still be supported. And also it'd still be supported to have encrypted keys. So in the key store, you could still store encrypted keys, but now the encryption of those keys is not clear. Before we had it that the encryption would occur by asking the server to generate the key and then passing in another key to do the encryption with. So we'd have to figure out how to support that. But I think we could still even continue to support the notion of having encrypted keys stored in the key store. Okay, so pros and cons of this approach. The pros is fastest closure. We can, take this to really last call as soon as the editorial edits are made to described above. The cons is that then there'd be no ability. We would have no ability to ask a server to generate keys, at least not until someone else picks up this work, right? So, on that point, I'd like to note that it is security best practice, long-standing security best practice to have for a private key to never leave the cryptographic boundary that it's intended to be used, at least not in its unshrouded state. And by shrouding, I mean like when we talked about encrypting the key, that's shrouding the key. So then it's safe to export the key in its shrouded form outside the server. But if you're having a client generate the key and then passing it in, that's the private key actually existed outside the server initially. So it goes against that best practice. And that's the one thing we're losing. We may also be losing some usability, right? There's some convenience to just being able to ask the server to generate the key as opposed to the client needing to do it themselves. And then as far as someone else picking up the work, I think potentially it could be, in theory, it could be months, but it's more like years until we would pick up this work. The other con I'd mention here is that while it's true that the key format can really save the day, and allow the whole entire solution to continue to function, the one place where it kind of fails is that there is one key format for symmetric keys called an octet string. Really, it's just an array of bytes. So there's absolutely no ASN1 structure to it. It's not clear if it's those bytes are being used for an AES or a triple DES. It's not, there's all sorts of things that are unknown about it. So if we wanted to use symmetric keys, we may have to get rid of the octet bytes symmetric key format and instead only use the one symmetric key format. So one symmetric key is really it's part of the CMS structure, content message syntax. It's a structure, ASN structure. So but then it can be used to support the symmetric key. Previously on list, we discussed how the one symmetric key and its corollary, the one asymmetric key, are not really as friendly as the native key formats. They're not typically what the tools generate. Like for instance, if you're using OpenSSL, it's not going to generate a one symmetric key for you, or even a one asymmetric key. You would have to code it using your own libraries, ASN.1 type library. So it's not very user friendly or even developer friendly, but it would allow us to continue to support symmetric keys. The good news, actually, while I'm mentioning here it's complex, it's also something that would likely not be used very often. Symmetric keys are not often used. In fact, the only reason we introduced symmetric keys it's not for TLS or SSH, right? Because they're always using asymmetric keys, and so the only reason for us having introduced them as symmetric keys in the first place was to enable the encrypting of private keys, so that we could do the shrouding and enable RMA type activities. So those are the pros and cons of option 3. Next slide, please.
So Ken, before we move, we have a couple of questions. Do you want to take them now or at the end?
Well, the next slide is, in fact, to take questions. So just go to the next slide. And so now we're really just back to the previous slide, and the 3 options are on screen and opening up for people with their thoughts. And you see Robert, I'll unmute. I think I remuted you. Okay, go ahead, Robert.
Can you hear me? On the previous slide, actually, I just wanted some clarification on the algorithm field. So you're saying that if you remove it, you don't really lose very much. Am I right in understanding, therefore, that the algorithm field is used both to be able to, when you're generating a key, tell it what parameters you want to use, what algorithm, and also in this case of the octet string key format? Is that the 2 cases where the algorithm type field is actually required? It's not required in other cases.
Yes. I'd say the 95% use case of the algorithm identifier was for those 2 RPCs, to generate a symmetric key and generate asymmetric key, so that you could tell the server what kind of key you're trying to generate. So that was the primary use case for the algorithm identifier. That said, it was always a good idea to sort of just have it, presented, usability to make it visible. And then, as you say, for the octet string or for the symmetric key.
Okay, and then I've got another question on your previous slide, so the option 2 slide. I think that suggests moving RPCs to protocols. Does that, so the SSH, so the RPCs become finding SSH TLS layers. Does that mean you would take the RPCs out of the crypto types? Yeah, because it feels very strange for me for a types module to define RPCs.
Okay. Well, indeed, it would be to remove them out of the cryptotypes gang module and move them. And so actually, I'd probably continue. They'd probably continue to be called the same thing. It'd be called generate asymmetric key, but it'd be in the TLS namespace versus the SSH namespace. So that's so it's, we wouldn't have to necessarily call the RPC itself generate a TLS key, for instance. But yes, the idea is to move them over into those SSH and TLS specific drafts modules.
Okay, so my third comment here is this seems to me like a nice approach. I will either defer in the whole issue and solving it later, or I prefer this option, I think, to option 1. But then Rich made a comment that this con is a pretty big con. Is it possible for you or Rich to expand on why that is the case? Because that's made me wonder if I'm thinking the wrong thing.
Well, so just quickly, I'll say something and then I'll let Rich respond as well. But if so, the list of asymmetric key primitives, primarily, RSA is sort of the 800-pound gorilla in the corner. But then there's curves, elliptical curves, And if you ever did in OpenSSL, you know, you ask it to list curves, you'll get a dump of around 88 curves, I think. And it probably, you know, it depends on compile options, but there's a number of curves, and so, you know, in total, there's, you know, around about 100 primitives that we're dealing with. Now, in my mind, that actually, the number of primitives that there are doesn't really matter, because it's all, you know, programmatically, you know, processed, and who cares if it's 100 or even 500. I don't know if that would really matter from a usability perspective. So with that, I'll see if Rich has anything to add.
Yeah, sure. Just to clarify my point, I mean, when I said it was a big con has other meanings, but when I said this con thing was a big one, I mean, it's actually, from the security viewpoint, how to say it, a key identifier, like an RSA key, as Kent said earlier, is an RSA key, but how it's being used, that is not protocol independent. I mean, what TLS does with a key, an RSA key, to sign a hash and prove its identity that way, is different from how SSH uses keys to generate, to verify identity. And so it's not, you know, using an RSA key in TLS and an RSA key in SMIME, we are signing or verifying arbitrary content as opposed to content that comes from a mix of two parties. That's, you know, the security folks would rather see those things as independent and put in the protocol layer, as opposed to the, you know, in an opaque crypto layer. RSA is RSA only in an academic sense. I hope that helps.
Well, Rich, if I can just follow up on that point. So there's this notion, for instance, with X59 certificates for key usage, and the key can only be used for signing or for encryption, and, you know, digital signature, et cetera. And I think it was Russ Housley who suggested also we could add to our key types in the crypto types layer this notion of attributes, so kind of mimicking that idea where, you know, the key was known to only be used for signing versus, you know, signature, versus encryption. Would that resolve the statement that you just made now, or is there even something additional that you're trying to say?
That would probably result in it. I know that, I mean, in essence, that's kind of what you're getting by putting them in the protocol layer, is you say, oh, this is an RSA key used in SSH, and therefore that implies all of what the SSH uses are.
Okay.
As opposed to, this is an RSA PSS key or RSA key in TLS, which implies a particular, you know, it's either part of the static key exchange in 1.2, or it's part of the signature, it's part of only the server identification in 1.3. So, yeah, you could do that, but I would think the security folks would be happier with having it. And I'm not representing the entire security community, right? They're like economics. 9 people will give you 10 opinions. But yeah, it's doing the same thing, but you have to think about, well, now you have to think about what the registries are, and you have to get deep subject matter expertise from, say, what SSH does and what TLS does, say, with an RSA key, depends on what version it is, right? Whether it's, it was a big change in TLS 1.3 where we use only Diffie-Hellman, whereas before you could have used RSA to do the key exchange too.
So I actually need to cut the conversation here. We're running over time. Jason, very quickly, because I really want to move to the next presentation.
Okay, I've got 2 parts quickly. One's just a comment. I'm also I'm not sure how to evaluate option 3 versus 1 and 2, but out of 1 and 2, I'm in favor of 2 as well. I think, you know, maybe theoretically a global registration of all methods is kind of nice, but I think the way most, let's say, users who are somewhat versed in security issues but not security experts, I think they're going to rather be focusing on their protocol, what's relevant to the protocol, and kind of adding this extra annotation to say, well, this is how it's used in SSH, this is how it's used in TLS. Again, maybe theoretically nice, but it just seems like 2 is nicer in general for the users of the module. That's a comment. So, my other question is, in option 1, why are we going with an enum there instead of an extendable identity ref? Is it because we actually specifically want to prevent kind of extension of it?
The discussion of that goes back to a few months back, and but to be honest with you, I don't think that we should use a meeting time at the moment to look at that.
Okay. Fair enough.
Rob,
I'm fine with deferring that.
okay, our AD has he's in queue to make a comment.
Yeah, so my question really is how do we get this to conclusion? Because these drafts have been here for a long time. I know there's other models waiting on these, so it's a question to Kent as an author and Kent Mahesh as chairs. What's the best way to sort of resolve this? Get to a good last comments.
I was going to ask that.
So as chair, I think we can take this to the list, but if we were in the room, we'd do a hum. It sounds like 1 is out. It's between 2 and 3. We could do a hum and try to get closure on it that way. So I think we should do the virtual equivalent of it after this call.
Yes, so that too, but what about and does this affect all the drafts, or do you think there are some drafts we can start proceeding to last call?
Well, this is in cryptotypes and also somewhat in keystore. So those 3 drafts that we're trying to bring to working group last call immediately are the 2 of them are affected by this decision. We need to kind of do this first.
Okay.
All right, great. So that's in the end of the presentation, and moving back into chair mode. The next presentation is by Mahesh. This is the working group draft for HTTP notifications.
Okay, are you guys able to see the slides?
Yes.
Okay. All right, so I'll be talking about the HTTPS-based notification. So the update since 01 is in the draft, we added the ability to learn receiver capabilities. We put in an example. The example essentially demonstrates that if the capability where we can either do JSON or XML, with of course JSON being the mandatory encoding, and that this is how we could use and learn the receiver capabilities. And you've left the option open for, of course, for future encodings if you want to define and to learn the receiver capabilities. So that's as far as the protocol change is concerned. In the model itself, there were 2 changes that were requested by Martin. One was to rename the receiver to HTTPS receiver to give it a better name. And then the second recommendation he had was to change the top level container to actually augment subscribe notifications. So both these changes were made in 02, and the examples were also updated related to that. So talking about receiver capabilities, subscribe notification has an encoding leaf that is defined, but it is, if the leaf is not set, then the publisher must discover the receiver capabilities. That is the encodings that need to be supported. In the example that we demonstrate in the draft, to discover, the publisher sends a GET request and sets the accept types that they would accept. In this, again, JSON is the default encoding. In the particular example in the draft, the receiver does support XML and therefore responds in an XML format with the list of supported capabilities. The example we give here is to say that it supports binary encoding. Now, I believe subscribe notification has an encoding defined for CBOR. So if the binary encoding is CBOR, actually that's what would be indicated in the response. Finally, the issues being tracked in the on GitHub is the fact that we need to have the binary encoding capability registered with IANA. And actually, there's a second issue that I need to talk about, which is should encoding be mandated? So I'll talk about that in the slide. So the question to the working group is it a need that should make mandatory to implement encoding? Subscribe notification draft is actually silent on it. It differs, I believe, and Eric will correct me if I'm wrong. It differs to the transport document to define what's mandatory, if any, to implement. Since it's not dictated, the question to the working group is, should this document pick one encoding that both the publisher and the receiver should implement? Or the other option is we require that the publisher support both XML and JSON, or that the receiver support both XML and JSON, such that at least there is one communication channel that's open. So any opinions on this from a working group perspective? I got a confirmation from Eric saying that it is correct that the transport document is the one to select mandatory encoding. And we have a question from Robert.
So I don't know the answer to this. Have you expressed a preference for this? So do you have an opinion?
Would you say that we have a preference?
No, I do not have a preference.
And if you're going to mandate one, which would you mandate? Because I'm a bit worried about mandating, say, XML when it is with the newer protocols and things that XML is not so in vogue.
Well, and similarly with RC 8040, we did not mandate JSON versus XML. So it kind of follows that mandating anything is questionable.
I think that'd be my view too.
So if you're not mandating, are we then requiring both?
Yeah, so then we fall into the OR clause. So for interoperability reasons, either the publisher must support both or the receiver must support both.
Would say the publisher chooses what it wants to publish in, and the receiver has the choice to support one or both depending on how much interrupt they want.
Okay.
So I guess
let the market decide on what I'm saying.
Right. So you're saying the publisher supports both XML and JSON, and the receiver can choose which one they want to support.
No, I'm saying that the publisher can choose to support one or both of them. They decide, and the receivers, obviously, depending on what publishers they need to interoperate with, will either support one or both of them.
So it's not guaranteed interoperability, but the market will figure it out.
That's my impression.
Other comments? We have a comment from Jim. From Eric. Sorry, first Eric.
Just one note is that if you have a subscription started message at the beginning of this with different encodings, you can always not okay the subscription started. And that is a way to say whether you're supporting an encoding or not. Is you're supposed to be able to okay the initial subscription started message prior to sending, and that's to stop you from spamming things. So if your receiver doesn't accept it, it shouldn't be sent if it doesn't accept an encoding.
So Kent, as a contributor, or actually as a co-author, this is not a dynamic subscription. This is a configured subscription. Correct. And we don't really have the protocol. There is no subscription started message to okay.
There's a subscription started on the configured subscription initial notification.
Well, it's not in the document. It's not in the draft currently. Maybe we should circle around and take a look at that again.
Yeah, I think it might be worth looking at the state change notifications that start the document to ensure that you okay the subscription started. It is in the base draft.
Next comment is from Tim.
Hi, can you hear me?
Yes.
Yeah. So I'm just thinking actually why you don't just make a publisher to advertise the capability of what kind of encoding it support, and then receiver can select it, but it maybe only apply to the dynamic subscription. You won't, because in your cases you focus on the configured subscription, right? So my proposal is publisher can advertise the encoding support, and the receiver can select one of the encoding. So but maybe this only apply to the dynamic subscription cases.
So that is essentially the same as what Robert is saying, right? That, well, not really, but you're saying it support, the publisher can decide between XML and JSON, and then the receiver then has to pick one, that encoding, right?
Yeah, but we have a relevant draft to talk about telemetry data export capability. Maybe
Right.
could be
Yeah.
leverage it. Yeah.
Right. So this is actually like Jim's other draft. So that selection is actually the reverse flow of what this draft is doing.
Yes.
Okay. Okay, I'll put a comment for that. Next in queue is Balash.
Actually dropped out of the queue.
Oh, thank you. Next in queue is Thomas.
About encoding, we have three possibilities, right? XML, JSON, and CBOR. Why not mandate that one of these three encodings needs to be supported? Leave it up to the industry which one will be adopted.
Did you say three?
XML, JSON, and CBOR.
So are you suggesting, although that was something that we are proposing as capability advertisement, this is initially at least for the setup part. So CBOR is very much thick encoding we want to support as part of receiver capabilities advertisement.
Correct.
Okay, I think next we have Robert.
So just one question to clarify is, when you said these are configured subscriptions, at the point you configure it, does the client have an opportunity to specify what encoding that they want the publisher to use? Or is it entirely up to the publisher's discretion?
Kent, do you want to try to answer that question?
Sorry, Rob, can you repeat?
Is this for configured subscriptions?
Only for configured subscriptions.
So does the configuration allow the client to choose what the encoding is, or do they just
Yes. Yeah,
so
actually, yeah, this is a very subtle point, and I'm glad you brought it up because I don't think it's been highlighted. It is in the draft. It's highlighted in the draft, but in the subscribe notifications now in RFC 8639, I think, there is a node called encoding. And that node is an identity. It has values such as encode underscore XML, encode underscore JSON. Those are the only two defined identities there. And but it's an optionally specified node. It doesn't have to be specified. And according to that RFC, it says that if it's not specified, then the encoding must be determined through some out-of-band means. So really, what we're talking about here is in that then clause, like what do we do in case it has not been specified? Perhaps our out here is to just say, you need to specify it.
Yes, I don't know on that. Yeah, I don't know. I still think actually that just letting the server decide on encoding is probably fine.
Can I add one possible answer here?
Yeah, go ahead.
Now, one of the things that you can do in the exchange of capabilities is to reply back to a subscription started with some information that would let you choose that. This is all back to the original discussion we had, I think, an IETF or two ago, that the receiver or the far sign should be able to reply with capabilities in the response message. So one way to handle this is to allow something to come back as part of the transport message that allows information to be signaled back. We can talk offline if you want.
Okay. All right. Yeah. So we are running way over time, so maybe we should take the rest of the questions to the mailing list. Unless you have a quick comment, Robert.
Fine, I'll take to the list. Thanks.
Okay. Thanks. All right. So next we have Jason.
Okay, you guys hear me okay?
Mm-hmm.
Okay, so this is one of a series of drafts that are mostly being discussed in NetMod. Oh, I guess I should have changed this to NetConf, sorry. It's the same set of slides, but it's all related to the Yang module versioning work, where we're looking at how to describe when Yang modules end up with non-backwards compatible changes during their development, and how to describe that, and when Yang module development sometimes branches, etc. So this draft is part of that suite, and this one has some implications for NetConf and RESTConf protocol layer. So we thought it'd be worthwhile talking about this one in this meeting. Go to the next slide. I would like to make sure we just contain the scope of discussion that happens in NetConf, though. So the majority of the issues around versioning is being discussed in NetMod. We'll try to keep just the issues related to this draft in NetConf for now. And one of the big issues we have is exactly where will this draft live. We're thinking some part of it should probably live in NetConf, but that's one of the issues we'll talk about in a few minutes. And next slide. So a little overview of what this is about. This is an optional functionality. It's by far, more heavy-duty implementation work on a server side, fairly minimal on the client. This allows a server to support and advertise multiple schema versions. As an example here, a server could support their modules version 6.0.1, and they may also have the option of supporting a previous version of the modules, 5.2.3. And then there are mechanisms for the client to select which schema set it wants to use. So if you have a client that implemented, you did your OSS integration a few years ago, you upgrade your router, maybe that router will allow you to just keep on using the old schema sets, and you don't have to do some work to take into account some of the non-backwards compatible changes that might have happened in the latest version. There's a default schema set if a client doesn't request anything. So clients today can perfectly interoperate with this proposal. They would just use the default schema set, which can be configured on the server side as well, if desired. And schema sets are comprised of Yang packages. And so the concept of packages is being discussed in NetMod. It's basically a collection of module versions. Okay, next slide. Keep on going. So these are changes since the last IETF to the draft. This is one of the drafts in the set that has actually churned the most in this set of versioning drafts. One important change is we've simplified by removing the RPC that was designed before. We had been kicking around the idea of using an RPC to select the schema set, but we simplified things to basically have it so that NETCONF clients, the only possibility to select a schema is at connection time during initial capability exchange. So if a NETCONF client needs to use a whole new schema set, they want to back out and go to a different version or upgrade and use to a new version, they would disconnect and reconnect and negotiate the new schema set. RESTCONF clients use the schema set name in the request URI for each request. The other use case that's interesting that we kind of highlight now is this may be used not just for selecting different versions of a schema, but it might be interesting in some implementations to allow a client to say, hey, I want to use open config modules, or hey, I only want to use the vendor proprietary models. So you could allow it to decide between different organizations' gang modules. Next slide. We clarified what we're calling the basic unit of selection. The NETCONF client connects, he's going to select something, and that something is called a schema set. Basically, a schema set is illustrated on the right. It's a collection of which packages are supported in each data store. So it kind of describes every data store and what packages are in each of those data stores, groups it all together in something called a versions schema set. So in this example, you'll see we have our vendor config modules version 3.1.2 and 2.5.2. You'll see those supported in running. You'll see those supported in candidate. You'll see those supported in operational. But then there may be a couple of extra kind of state-related packages in your operational. And on the bottom left, you may see something totally different in a dynamic proprietary data store. Okay, and continue on the next slide. Okay, I'm going to move past this in the interest of time. Let's skip over the slide. Okay, here's another change that's kind of relevant protocol-wise. We had configuration for RESTCONF protocol instances. We've changed the proposal to just put the name of the schema set right in the request URI. So you can see an example at the bottom here where you can see the client is selecting vendor schema at XYZ. Next slide. Okay, I'll just focus on point 6, a little bit more key. If one NETCONF client, for example, selects a particular schema set, it has absolutely no effect on the sessions that are already up between other clients in the server. So the other sessions would continue as they were with no change in what they'd see in their schemas. It's per session and totally independent per NETCONF session. For RESTCONF, it's a bit different. It's every request specifies the schema set. Next. Okay. Okay, go to the first discussion topic, the next one. Okay. So one issue that's kind of protocol related here is we do have the capability in the draft that the server can support, maybe the server might support 3 different schema sets, but the operator can configurably kind of remove or limit the set that operator wants to advertise to clients. So the operator may, for whatever reason, decide, they only want to advertise 2 of those 3 schema sets for use because they may take resources in the server. When a schema set is removed through configuration, one issue is, what do we do with sessions, NETCONF sessions that we're using that schema set? There's a few possible options. One is disconnect any NetConf sessions that were using that schema set. Second, allow the sessions to kind of continue, but any new sessions trying to use that schema set would be blocked. And then the third is actually reject that configuration. Don't allow the operator to remove the schema set if it's in use. Our preference from the authors, the X design team, is option 1 to keep things simple. Option 3 would mean blocking config because of state and stops an administrator from being able to remove a schema set. So that's not so much preferred. I don't know if there's any other thoughts on this one. If not, I'll move to the next slide.
Jason, this is Kent as chair. I think the biggest question here is whether or not there's impact to the NetConf working group, and there's some discussion as to if these should stay all in NetMod or some of it should move to NetConf.
Okay, so that's slide 13. We can skip there.
Yeah, let's just skip to that.
One more slide, 13. Yeah. Oh, yeah. So this is the biggest issue for this group. I mean, there are definitely some impacts to NetConf in that there's an optional kind of advertisement from the server and selection from the client. And same with RESTConf. There's the ability to put the schema set in the URI. So yeah, one of the big questions is how do we tackle this work between NetMod and NetConf, and whether we take some part of this draft or this entire draft and keep it in this working group. So there are conceptually kind of 3 parts to the draft. It could be broken down all the way into 3 drafts. One is just the very specific NetConf stuff. Another is the very specific RESTConf stuff. And then there's some things in the draft that kind of are not necessarily NetConf or RESTConf specific, but are just more about this version selection process. So we could either keep all that together in one draft here, or split it into 3. So I don't know what the feelings are, maybe more from the chairs or others on that.
So this is Kent speaking as chair, and actually of both working groups. Knowing the charters of both working groups, NetMod is chartered to work on modules that may, for any working group potentially, if there's not a better working group for it to be in. And NetConf, of course, can work on Yang modules that are related to transports and whatnot. But NetConf is uniquely chartered to maintain the protocols. So not just modules, but not just defining modules, but actually the protocols themselves. If you want to make changes to the protocols, and only NetConf can do that. So to the extent that there's actually protocol changes, I think they must be done in NetConf and not in NetMod. So similar to the NMDA work, where NetMod, did the overall overarching solution, but then parts of it were factored into NetConf. I think we have to do that again for this work. And then as to within the NetConf, if it's 1 draft or 2 drafts, like a draft for NetConf versus a draft for RESTConf, that's something that the working group can decide. I personally prefer protocol-specific drafts. But that can be discussed later.
Yeah, the only. Oh, sorry. Someone else can speak.
I just want to see if Mahesh or Rob had a comment to that.
Okay.
No, so I second Ken's opinion. I think as far as the protocol work is concerned, that has to be done in NetConf. And I would say that, yes, in a way, the authors and the working group can decide whether it should be 1 or 2 or 3 documents.
Okay. I'm all for the. Yeah, I'm all for the idea of keeping this work in NetConf. I think my slight preference is to keep it as 1 document, only that I mean, conceptually we could split it into, it would have to kind of be 3. but I think they're going to be so interrelated, it may get a bit confusing, especially if we move the third one to a different working group. So, I mean, maybe one part is to progress it as a single document initially and see how that feels as it progresses.
All right, so final comment
Can
from
try this.
Robert.
Yes, I agree with the chairs here. I think doing this in NetConf is the right choice for this draft. And then I agree with you also that taking it to the list to determine whether to split it into 3 documents or keep it as 1. And I agree with Jason that to start off with, let's keep it at 1 and then work out if it can be split. It needs to be.
Okay, we really have to get going unless, Jason, you have anything else you want to talk about?
No, that was the key issue. We can move on. Thanks.
Okay, next slide is our presentation is from Chen on self-explanation data node tag capability.
Okay.
Can you hear me? Okay. Yeah, hi everyone. My name is Chen Wu. I'm here to discuss telemetry data tagging capability draft. The title we give is self-explanation data node tag capability. This is not a new draft. We already presented in next slides. We already presented in last Singapore meeting. Actually, one of the issues is how it is related to the notification capability draft. And the change we made in the since in the latest version, actually we try to align with the system capability model that defined in the notification capability message capability draft. So we introduced several additional telemetry data tagging parameter in the registration, also in the models. Next. So why we write this draft? Actually, as we know, IETF already developed a large amount of device model or network element model, such as BEP, ACR, and the vendor also proposed a different vendor-specific model. All these model can be used as a data source. If we capture all these data, all of this telemetry data from this device model, actually, it will cause massive data connection and processing in the network side. From the connector point of view, actually, when you establish connection with a device, for the next step, what they need to figure out what kind of telemetry data they can fetch or connect. And this is usually rely on the pre-configured selection filter or subscription policy. And this subscription policy or selection filter either can be either specified by the NMS or instructed by the device. So next. So what we like to do is we define the telemetry data tagging capability model. Use this model to advertise what kind of telemetry data you can capture to help the client to capture the characteristic data from the device model. So the big benefit, you can identify the performance measurement related data for service assurance application. In addition, they can provide network visibility to various different category data like network node, traffic flow capacity. And so also you can provide like a tendency prediction, threshold-based telemetry, anomaly detection. There's many benefits to do this. Next. So what is telemetry data tagging? How do we classify these telemetry data? Actually, we define the 4 typical telemetry data tag. The first tag we call the OPM tag. It's an abbreviation of the object type, property, and metric. And this can help to capture the characteristic data of the telemetry data. And in addition, we provide the fine granularity of OPM tag. For example, when you connect the performance metric value, this value can be the maximized value or minimized value. So we can use the operation type tag to indicate this. In addition, we can provide the metric precision or metric scale for this OPM tag. And the second category we call the service tag. Actually, for data object we observed can be used for the multiple purpose, So we can use the service tag to describe each purpose. And one of the example, you may have L3 VPN service, you have T tunnel service, you can use a service tag to do that, to represent a different service. And in the third category, we call the data source type. It can be used to identify different data sources that relate to the connectivity, resource, hardware. And the last one we call the parent grouping. Actually, this is something related to the multi-source aggregation. Suppose you connect the performance metric. This performance metric can be connected from different source, for example, a line card or sub-interface. So you need to figure out which performance metric from which source can be correlated. So we can use the parent grouping to do that. Next. So how do we use this telemetry data tagging capability? Actually, we give the example. You can actually to capture the performance measurement data using the OPM tag, and you can advertise this kind of capability from the device to the client. So client can know how to specify the dynamic subscription, send the subscription message to the client. And so in this way, we can provide a multi-dimensional telemetry data analysis. Next. So second case we call the multi-source telemetry data aggregation. So in this case, you may connect the performance metric from multiple sources, for example, from multiple line card. So you can use parent grouping to indicate which performance metric, for example, LSP average latency, from which line card need to be grouped together, and you can advertise this capability from the device to the client, so client know how to specify the dynamic subscription message. Next. So this is the model we propose. We actually augment from system capability with a set of the telemetry data tagging. We actually classify them into 4 categories. For example, OPM tag, service tag, and data source type tag, and a parent grouping tag. And so we can use, so we augment, use this model to advertise the different tag from the server to the client. Next. So for telemetry data tagging capability, we can use this to capture the characteristic data to correlate the data object from different model, provide a good network visibility analysis. So we think it's very useful to have this kind of work. We would like a working group to consider to adopt this kind of work. Thanks.
Any questions? Okay, so to the question of adopting, I mean, this has been presented a few times, and I think that, again, we'd probably want to get a sense from the room in terms of adoption. We could take it to the list for virtual hum. Oh, I see that Balaj is in queue. Balaj, do you have a question? Comment?
Do you hear me?
Yes.
So for me, this consists of 2 parts. One is the idea that some of the counters or measurements telemetry needs additional data to specify what kind of counter it is. The other is the exact set of counter or exact set of properties. I think that will be more difficult to agree if we adopt this. For example, I'm working also in 3GPP, which has a very different idea of what information we want to know about counters and measurements, and others might also have different ideas. Thanks.
Okay, great, thank you. And we are over time, and Chin, I want to ask you not only as a presenter, but also I believe someone who is involved with pretty much all the drafts that are remaining on the agenda, if you would like to somehow coordinate how much time each or which ones get presented and how much time each. If not, yeah, go ahead.
Yeah, we have other 4 relevant chapter. So what do you propose to do? You want to?
Well, we can continue with the existing agenda, but we'll run out of time probably.
We try to make it short, actually. Yeah.
Yeah, on Pierre-François here, I can make mine short, Mahesh, because it's Ken speaking, sorry. Due to your request to talk about the why instead of the content, actually, I can present my slide 1, 2, and then 8 and be done with it, and then leave the time to Benoit. So if you want me to make it in 5 minutes, I can do it in 5 minutes, no problem.
Okay, so it sounds like we'll continue with the existing agenda order. So next is Peng presenting bulk description to Yang event notification.
Hello, this is Peng from China Mobile. Do you hear me clearly?
Yes.
Okay, thank you, everyone. So it's about a bulk subscription to Yang event notification. Next slide, please. Okay. The subscribe notification draft allows users to subscribe to the event streams that they are interested in, and notification message headers. Sorry, next slide. Okay. And bundles defined in draft notification messages allow bundle multiple notifications into one single transport message and use subscription ID for identifying the target. But there are also some problems that the subscription protocol operation doesn't provide specific criteria to classify subscriptions, and therefore lacks the capability to explicitly indicate which specific subscription associated with a notification should be bundled together. And we'll give 2 examples. The 2 subscriptions can be bundled based transport and encoding parameters, and they may also be bundled based on the relationship with a set of Yang data models. So we think these problems may not be solved at present. And in this draft, we define the Yang data model and the associated maximum, which allows subscriber applications to bulk subscribe to publishers event stream based on group identifier. So this allows the publishers to report notification single message. The next slide, please. So there are 2 use cases for bulk. One is dynamic subscription. In the dynamic subscription, the subscriber may have already had primary knowledge about correlation between subscriptions, like aggregated subscribe data from multiple with the prior knowledge, it might send a bundle subscription request to indicate what specific notifications associated with the subscription must be bundled together. For example, user A wants to package subscriptions 1 to 3 together, and so the client or users can establish subscription including the nodes powerful bus and the device response with the ID 1 to 3. So the client knows send the bulk subscription RPC to the device, so the device can give the bulk reporting. And in the reporting, we think multiple notifications corresponding to the request protocol operation for those notifications are bundled into one transportable message and using notification message headers and bounds defined in notification messages draft. And the next slide, please. The use case 2 is configured subscriptions. So different from the first use case, sometimes a subscriber may not have prior knowledge about correlation between subscribers. So in configured subscription, you can use the self-explanation data nodes tag capability advertisement, which I introduced in the previous presentation. And it may describe the correlation between data nodes in different young data model from different publishers, and can be used to further establish correlation between subscribers. So in we can see from pictures that users want to package subscriptions that marked as full together. So there is a telemetry tagging capability advertisement. Both of the full and the bar nodes are in the same tag. So the client can infer that they may have a correlation, so it can generate the bundle subscription of them. And next slide, please. We can give a solution overview of it. The augment of bank subscription. There are the additional subscription criteria. One is max bundle latency. The maximum latency before specific YAM notifications generated must egress a publisher. And this attribute enhance use features. And we think it can provide additional subscription bundle classification criteria. And another is compression algorithm. Is that if some subscriptions has the same compression algorithm, we can bump them together. And the subscription ID indicates which must be bundled together, and it can also indicate which must not be bundled together by masked subscription ID. So next slide, please. And we think the bank subscription model can improve data collection efficiency and expand data collection performance. And we hope to work together with message bundling if anyone interested in it. So thanks. Any comments or suggestions?
This is Kent as chair. I'm looking at the agenda. I note that the remaining presentations are all related to subscriptions and telemetry data, which is great that there's so much interest from the working group participants in this area. And then the question, I mean, that's the observation. The question is, to what extent has this, or and I guess for all the remaining presentations, are there implementations? And is there any? Are these just ideas, or is there some code that's you're working on the code?
Okay, sorry, do you mean that is the ending of the work?
Right. So, have you prototyped this idea yet?
Kent, yeah. Kent, this is Qing. Actually, we are working on that. Actually, for some of the idea we propose that has, some prototype, like adaptive subscription, and some of us actually we actually plan to prototype.
Okay. Yeah, I think that would be good. I mean, if we get like an overview, not just this presentation, but all of them, and also Eric, I think some work that's going on in your
briefly about the status of the draft I'm presenting on that matter. No problem.
Perfect. All right. With that, the next presentation is also from Ping, telemetry data export capability.
Now is telemetry data export capability. In the subscription with use case, which refers to it, and
Thing. Your voice is fading out.
Okay, so go to the slide, next slide, please. The notification capability modified in notification capabilities allows a client to discover a set of capabilities supported by the server, like basic system capability and YAML push related capabilities. And this capability permits the client to adjust its behavior to take advantage of the features exposed to the by the device. The problem is that pre-configuration for some transport-specific parameters, like transport protocol, encoding format encryption by the client is still inevitable, which may cause unexpected failure and additional message exchange between client and server. So, next slide, please. So this draft is to use telemetry data export ability to allow the client to subscribe data store nodes update with specific transport protocol, encoding format, and so on. We think about providing those capabilities like dynamic or configured subscriptions with adaptive telemetry policy rule. And provide a notification message bounding if the device enables message bounding support per subscription or per data store node. And also provide event-based telemetry if the data store node can handle threshold value. Okay, next slide, please. And we also give 3 use cases for it, combined with bulk subscriptions and adaptive subscriptions, which will be presented in the next. The first use case is negotiation of subscription policies on transport protocol. So we can see first is the telemetry data export capability notification from device or server to the client. Then the client can specify transport protocol and encoding format in the dynamic subscription. And finally, the YAML notification for data store updates with specific transport and encoding. And if it doesn't have the capability, then the client need to understand why the previous RPC request for specific transport failures relies on error response to a failed RPC. Yes. And the next slide, please. And the second use case is about the message bundling support. So you can see first the capability. First is data export capability notification about bundling. Some servers or nodes may support bundling, while others are not. So the client can generate subscriptions dependency policy. Then the bulk subscription to this store nodes update based on the dependency. Finally, it can have the this store node updates for a set of specific notifications. And if we don't have the notification, the client may not understand the bundling policy and then drop all of the message from the server. And next slide, please. And we also have the third use case is about the policies on threshold support. So in some case, we may have to adjust the threshold and change the policy to track the data. So we can see first the notification about threshold support for specific node. And then the client can design event-based telemetry policy. For example, when 4 is higher than 4, it will trigger YAM notification for a set of specific data nodes. And next, client will give configured subscription with event-based telemetry policy rule. So finally, the device can achieve it. And without the notification, client may fail to configure event-based telemetry policy rule. And the error response freedom RPC request may not able to tell what event-based telemetry policy configure fields if no new error code is specified for threshold not support. I think we passed it. So please change to page 7.
Sorry, which slide did you say? 7, right? Okay.
Yes, because I haven't noticed that we are not going to the general C. Yes. Okay. So we can see the data node capabilities module. There is augment which includes transport protocol, coding format, secure transport, and so on. It the banking subscriptions and adaptive subscription. Those proposals are augment system capabilities model and YAM push capability model. And it can also provide additional data export attributes associated with system capabilities and YAM update. So next slide, please. So we think the key value providing flexibility to select different transport-specific parameters and detect whether the device supports message bundling or threshold-based telemetry and therefore avoid unexpected failure and additional message exchange between client and server. Can we call the adoption rate as a work item? Any comments? Thank you.
We have a comment from Mahesh.
Right, thanks, Kent. So Peng, the observation that Kent already made is that, with a lot of these drafts, the exchange of information is in the opposite direction from the receiver to the publisher. My question to you is that isn't the transport protocol pretty much decided at the time of implementation itself? So, for example, if I'm going to implement the HTTPS node of draft, which is the workgroup document, isn't the transport and its security already decided by that implementation? Similarly, I think the HTTPS node of draft already supports message bundling. So isn't it just a question of saying, I want HTTPS node of, and then everything else kind of falls in place? Shane, do you want to?
Actually, yeah. I try to answer your question. Actually, I think because this capability advertisement is used at the implementation stage, actually. So the device or the server or client maybe support different transport capabilities. So they need to negotiate with each other. So we think that some device may support, for example, UDP transport, some device support TCP transport. This need to be known by the client, so client can select the right transport protocol. So this is just one example. Some other example, maybe they support different compression mode. So the client can select the right compression mode. Also, the message bundle support is another example. So
Right, which I agree. So I'm saying that, say, you decide that you want to use HTTPS-based notification as a way to transport the messages. The implement.
My understanding is they complementary to each other. Actually, you assume, the YAM push separation, the encoding actually is optional. You may not set encoding, but our assumption is we can let a publisher to advertise the encoding to the receiver. The receiver to select the right encoding. So this specify the encoding in using YAM YAM push subscription messages. So yeah. So I'm not sure this is something overlap with what you proposed in the HTTP notification. I think this is something complementary because your proposed dynamic receiver capability discovery is happen after YAM push separation message that is sent from the client to the server, right?
Yeah, but maybe I should let Robert ask this question. I don't want to take the time since we're running late anyway.
Just a quick comment, not so much on this draft, but more generally, that there's obviously a capabilities YAM model that's almost, or drafts are almost done, and there's a few drafts that are augmenting those capabilities. And I think generally capabilities is something that needs to be solved, but I have a slight concern that we're adding to that on the fly, and whether we, as a working group, should be trying to look at capabilities as a more general issue and working out what the long-term strategy should be for capabilities in Yang. I just have a slight concern that we are developing a solution on the fly here without really knowing exactly what we're aiming for. So to look at that Yang model, one particular example is, for example, your transport protocol that's a leaf and coding for that's a leaf, but I'd have thought those would need to be a leaf list or something that you could support multiple transport protocols or encodings rather than a single leaf. So, so my comment is basically, I wonder whether there's a bigger underlying issue here that we need to understand.
I think that's a good comment. Actually, we can allow the server to support a multiple transport protocol to change the leaf into the leaf list. It's an option we can do. We can improve step by step for this. But I think notification capability provide a generic capability model. This allow model extension, and so for transport specific parameter that need to be negotiated. Without this transport parameter negotiation, you need to do the pre-configuration, or without the pre-configuration, you may need to end up some failure. You may use the RPC reply to indicate that will cause additional message exchange. So we think probably we need to have this kind of transport telemetry data transport capability.
Rob, as chair, the notification capabilities draft is a post working group last call, but I've been holding on to it because there was a required instance discussion that spawned out of it. I think it's currently being resolved in NetMod working group. But to your comment, are you suggesting that perhaps we should maybe see how this work should be incorporated there, or can you restate your comment?
So I think the existing capability, capabilities draft should progress as before. I don't want to slow that down. It's got a key need for that. My concern is more generally that the whole issue of capabilities is wider than just these particular points. There's lots of different capabilities that devices have, and having a very general solution for capabilities would be useful. And I don't quite know whether that model is sufficient longer term. I just think we should try and look at all those issues, understand what they are, and make sure that the solution that we're building encompasses everything that we need it to do, rather than just solving a few point concerns, if that makes sense.
It does, and to level up this conversation. I mean, again, looking at the agenda, there's so much related to notifications here. I'm almost thinking that perhaps we should consider having a design team to really focus on this holistically, and then bundle it all up as. I mean, I almost feel like we need a presentation for the presentations at this point. They seem like a bunch of disjoint efforts, and that concerns me.
Yes, I echo that.
I fear that some of these arguments, when I changed the drafts to include generic capabilities, because there are so many capabilities. So if we keep on discussing all of them, the drafts will take, at my draft, the notification capabilities will take another 3 years. So I am very happy to hear from Rob that that can proceed. And although I support that we should have a general discussion about capabilities, but please don't keep my this draft on for another 3 years.
Okay, great, thank you. The next presentation, I think we should move to it. This is Jim presenting adaptive subscription Yang unification.
Yeah. So, hi everyone, my name is Qing. I'm here to present adaptive subscription. This is a new draft. Next. So this draft, related to the Yang push subscription, and the Yang push subscription allows the client to subscribe the continuous data store update without pooling. And right now they support two kind of the subscription mode. One is periodical subscription, which has fixed update interval or periodic update interval. The second is unchanged subscription, which will be triggered by data store content change or by the protocol operation type change on the data store content. This Yang push subscription will be used between the client and server. But in some cases, both client and server or both connector and publisher may be configured with multiple periodic interval. Actually, this multiple periodic interval will be applied to the same set of data object. One of typical example is a wireless scenario. In you may the signal strength may change over the time, or through wireless throughput or per packet delay may be changed over the time. So this is mostly caused by the radio resource contention. So in this case, such cases, what we really like to do is adjust the sampling interval to adapt to the change of the signal strength or throughput or per packet delay. Next. So here is a use cases we call the wireless network performance monitoring. Assumption we made actually is we will see the wireless network performance as a good quality when the signal strength or radio resource strength indicator is greater than minus 65 dBm. And based on our experience and statistics, actually, when you connect 100 sampling points, usually more than 80 sampling points will have a signal strength that is greater than the minus 65 dB. Only less than 20 sample points actually with signal strength that is less than minus 65 dBm. So in that case, we expect to connect more sampling points with weaker signal strength. So we may change the sample interval into high value or low value. When we set the sample interval into the low value, and we can get a curve actually better reflect the signal strength trend. For example, you can identify the micro burst, or you can see the peak point or valley point up down in the curves. And but the price you should pay, actually, you may need to consume large amount of system resource. So another choice, you set the sample interval into the low value. high value. Actually, that means you not enough sampling point you can connect. Actually, you can just get a coarse ISSI time change curve. Actually, so our proposal is look over the balance between the system I/O resource consumption and the sample period value selection. So we can change the sampling period based on certain condition. Next. So this is a solution we propose. This is a model we propose. Actually, in this model, you can see actually we augment a subscription model with a set of the parameter related to the condition expression and interval that need to be switched to. And in a condition expression, the most important parameter is the threshold value. And so we need to make sure that data object we observe need support the threshold value handling. So we may use telemetry data tagging capability to notify whether threshold is supported, or we can use the data telemetry data export capability to indicate a threshold support for specific data object we observed. So we can initiate the adaptive subscription to so we can define the specific condition that should be met, and based on the condition we can change the interval accordingly. So next. So this is a usage example we provided. So in this example, we can monitor the voltage or power in the optical device. So we have optical box telemetry model. So to support adaptive subscription, we can define the condition expression and the corresponding period. And so you can see we can support two interval. With each interval has a different condition that should be met. Next. So we think for adaptive subscription actually is very useful to address the sampling performance bottleneck, and can identify some microbolts in some data visibility analysis or anomaly data analysis. And so we would like a working group to consider to adopt this as a working group draft. Thanks. Comments?
This is Kent as a contributor. Interesting idea. I was wondering also if it's possible to specify percentages. So for instance, I mean, when monitoring counters and whatnot, many times, or not counters, but things like voltages, it only matters when the value is changed by a certain percent. So as long as it's within a window of plus or minus 1 or 2%, it's not really interesting to communicate to a controller. But if it varies, plus or minus 5%, then it becomes interesting. So, some sort of relative subscription might be also an interesting something to consider.
Yeah, in the condition expression, we have 3 parameters we call the upper value, upper name, and the operator. Actually, these are generic parameter we propose. We actually can use these 3 parameters to support the percentage and some other case we may come up.
Okay, thank you. The next presentation is from Pierre. Subscription to multiple stream originators.
Actually, it's Thomas who's presenting it. All right.
Okay.
Everybody, can you hear me? Perfect. So it's subscription to multiple stream originators. So next slide, please. So this draft was first posted in July 2017. The working group adopted it in September 2017 and received its 10th revision by November 2019. Within the Unite project, which is a group of operators, vendors, and universities, we are currently working on an open source software for the data collection, and I actually want to have at IETF 108 hackathon a working solution and test it there. Therefore, we will submit this draft on March 2020. Next slide. So the main problem statement here is that as a network operator, we're seeing that SNMP is not scaling anymore. We see the movement going slowly towards Yang push streaming telemetry. And within Yang push, we want to give with this draft a possibility that metrics can be pushed directly from the line card without involving the route processor towards the collector. And that's in the line card, the route processor, that only is available within the distributed forwarding plane. In there, especially, lots of metrics can be exposed, and we want to make sure that that high frequency is actually not having any negative impact on the route processor, because we believe that the route processor, its main core function should not be forwarding metrics from the line cards towards the collector. It has other functions which should the route processor take care. Next slide deck, please. So these are the main software components involved. So on the collector side, we have the subscriber and the receiver, where the subscriber maintains the subscription at the publisher, where the receiver receives the metrics from the publisher. And the publisher, we have two roles, the master and the agent. The agent resides on the line card, where the master resides on the route processor. The agent is responsible for the component capability, where the master is responsible for the route to the global capability. So when the master is receiving the subscription from the subscriber, it further puts the subscription down to the component subscription based on the component capability of the agent. When the agent receives the component subscription, based on that configuration, it pushes the metrics down to the receiver. Next slide. So for the message generator ID, these would be the extensions on the subscriptions needed. So the message generator ID is basically that a piece of information which maps to which software, to which line card, which messages belong to. So it's a unique identifier. So at the data collection, we can relate which messages actually relates to which software component on the router. So in case of fragmentation, for instance, that the right fragments can be built together. That's for configured and dynamic subscription. So next slide. So for dynamic subscription, this would be the call flow. When the subscription is established, the publish master basically pushes down the subscription to the publisher agent. And when then in the notification messages are produced, it contains the subscription ID, which maps to the subscription, to the YAM model, to the schema, where the generator ID is mapping towards the software process, which is actually generated the messages. And further down below, you also see what's happening when the subscription is modified. According to that modification, and basically the message generator ID could change. Next slide deck. Configured subscription is almost identical. The only difference between dynamic subscription is that in this case, the subscription was established previously out of band through CLI, for instance. Otherwise, it's the same. Next slide deck. We would like to receive from the working group feedback and also from the mailing list, and would like to call for adoption.
Okay. Kent, are you there?
I am. I think it's too early to call for adoption this time. We definitely should take this to the mailing list, but there's a second presentation also. In the interest of time, we should move to that.
Sure.
So can I quickly ask my question, and then maybe it could be answered as part of the second presentation?
Sure.
So as a chair, I noticed that there were two drafts with the name subscription to multiple stream originators. So I was wondering why there were two drafts with the same name, and why was the other draft not reused if the content is the same? So that's one confusion that you might want to clarify. Another and more important question is this draft, as you noted, was discussed in 104 and 105, where both Tim Carey and Kent had raised a couple of issues around a closed ecosystem that was described, at least then. How does, and the questions related to anyone, how they discover a master, how would a subscriber know that there are line cards? So is that still in the scope of this draft or out of scope? I mean, you can choose to answer now or as part of the second presentation.
That will be part of this draft.
So you're saying it is in scope?
It is in scope, yes.
Okay. All right. And so you just, maybe you want to clarify with the other, why there are two drafts with the same name.
I have to check that with Tianran, which is the author of the draft, and from the previous draft, why this has changed. We will answer that on the list.
Okay. All right, so we can move to the next draft.
And there's only 2 minutes for the next presentation.
I take the challenge. Out of respect for Benoit, I'll take the challenge. I'll try. Okay, I'll rush this. Okay, so this is. Can I start?
You can, but well, actually, really, if you could just answer the question: are you presenting a UDP notification channel?
I'm UDP-based web channel. Oh, am I impatient here?
Well, no. I mean, just like Mahesh mentioned a second ago, there was a previous draft for the same name. And that draft was adopted, but then the working group unadopted it. And the reason why it was unadopted was because it wasn't presenting a notification, like a notif channel. We said, come back and define a notif channel. So it's, with that, can you please go ahead with the presentation?
Sure. So I'm Pierre-François. I'm a researcher at the National Institute for Applied Science in France. This is joint work with all the ones you know. Additional authors are myself, Thomas from Swisscom, and Paolo from NTT US. Next, yeah, no, sorry, previous slide. I did not know you were already on that one. Yeah, so yeah, as you can see from the history of that draft, this looks like a draft on live support. So I understand you're questioning the why instead of the how. So well, I'll try to do it quickly. So my own why is quite simple. In September last year, I got a call from Paolo asking me if I was interested in evaluating the performance of a YOA router that had been deployed in Thomas' lab at Swisscom, and which was blasting streams of UDP stuff from its line cards. So I said, of course, I cannot refuse an offer like that. And so currently the status is that we are playing with a test release in the lab, and if I understood correctly, we'll be using a main release soon. So regarding the why for the other people, so I quickly made a whole interview of the entire team and asked them a lightning explanation to make sure we are all agreeing on this. The operators basically told me we want choices, we want to extract the most from our boxes. They, of course, would like to have fully capable top-notch premium gears everywhere in their network, but how to say that, as Donald Rumsfeld was saying, you go to war with the army that you have, not with the army you may want to or wish to have it in a future time, right? So this is the reality of things. And then when you look at it from a technical point of view, well, to wrap it all up, what they want is IPFix, is a migration from IPFix to streaming telemetry without the loss of functionality. That seems pretty clear to me. Okay. Now, if we move to the last member of the draft, the Huawei teams and affiliated, well, when you ask them the reason why, it's getting pretty simple. Operators ask them for what you find in the abstract of the draft. Huawei proposed something, the operator said, go for it, and they did it, and now we're testing it. That's as simple as that. So now, if you want, you can move to slide 8. So, on the, I guess this will be the usual stuff on the working group doc adoption. So what I would say is that indeed, before we decide to adopt it or not, we need more feedback. We need more input. If you want us to write a draft with the names of operators that are telling us to go for it, we'll do it, no problem. If this is a problem of lacking of customer request, this is not a problem to find. One question that I have to the working group is that if this does not go through with the operators that are behind this, what do you suggest the community to do? Because we are going to end up with Juniper with their own version of it, proprietary, doing the same thing in a slightly different way. We have Huawei who's done it, and Cisco I do not know. So on this, if it gets into the working group status, and then in a later stage we decide to pick the solution of another one that gives us the same properties, fine, we'll kill the draft, we don't care, right? But if we don't do that, I'm going to have an issue finding how to proceed with the operators that are wanting this. So if you could work on clarifying those things, that would be nice. If there are no other questions, I think I can give the ball to Benoit.
So very quickly, Thomas, I think if you could answer the why, and if you go back to 104 and 105 meeting notes, the questions that were asked, if you could try to answer that on the list, that would help.
Sure, we'll do that. No problem.
Okay. For the last presentation, Joe, or is it Manish, who's presenting?
I can do that, Mahesh.
I should mention we are over time, but it's a virtual meeting, and for those who would like to stay on, we can have this last presentation.
Yeah, thank you. This is Manish.
Sorry, wrong presentation. Okay. What is the name of the
closed loop automation? Node capabilities for closed loop automation.
No, I was trying the name of the presentation.
It's node capabilities for closed loop.
I found it.
Thank you.
All right, Manish.
Yeah, thank you. This is a work that we've been doing here, trying to demonstrate you about the per node capabilities. This is specifically focusing on having an observable and providing some optimization related to those observable for operational data collection. So yeah, Mahesh, can you please go next? Yeah. So if you see at a high level, right, the servers, in the telemetry data that is exported out for post-processing analytics and closed loop automation, there is a granular information that is required for this telemetry data, right, to find and automate the collection, right? So that extra information is what we are trying to explain in this draft. Can you go next slide, Mahesh? Yeah. So one of the example of that information that we're talking about here is for like if interface counter is not updated more frequently than 30 seconds in the hardware, any collector, if it's polling, at a frequency lesser than that, would end up having wrong conclusion at their side. So having this information available to the client side, which is the collection side, is important here, so that they don't draw the wrong conclusion. Can you go one more next slide, please? Yeah. So this is just a little reminder that there is already these two drafts, IETF system capabilities and IETF notification capabilities. We are adding another draft using IETF system capabilities via augmentation. Can you go to the next slide, please? Yeah. So this is about IETF system node specific metadata that we are proposing here. And what we're doing is augmenting IETF system capabilities to provide the capabilities so that the optimum operational data collection can be achieved by the clients. We also provide two RPCs to simplify some of the operations, that can fetch the information at the real time for the granular telemetry metadata. I'll take an example on the next slide to demonstrate that. Yeah. So if you take the Yang model data tree, the information that we are augmenting to system capabilities node selector per path defined in the data model. One of the things is minimum observable period, which is basically this information will allow the collectors, allow the client sides to know what is a minimum period that they can subscribe the stream for on a node selector, right? So right, and then we have the suggested observable period, which is telling from the vendor perspective what is the suggested observable period that this path can support. This value can come from profiling done by the vendor. And at the same time, based on the implementation, if they have a constraint about what is a hardware capability for minimum, but there is a software constraint around, so what's a suggested observable period for that node selector? Then there is a concept called optimized measurement point. So this basically is an empty type, which means a particular node selector when a client is requesting the metadata associated to on the device. If a node is having this leaf node optimized measurement point, that means that particular XPath is on the device is implemented as a most optimal point where the collection should. To take an example, in some of the server in the Yang data model tree, bunch of leaves are grouped together in where actual collection is happening. So it's optimal to collect that data in one shot versus collecting individual leaf inside that group of data. So again, implementation can have a more optimization specific techniques here, but the idea is that to export that information to the client side so that they know what exactly XPaths inside a particular data model are the most optimal measurement point for them to collect the data. So this basically represent that point. We have this this code also. This is not only a concept. This is also implemented idea. And then we have this is a bunch of additional informations required, like just telling, corresponding MIB ID and a related node. This is self-explanatory. The related node basically is for non-MDA compliant implementation. What basically is interested is when we are exporting the data for, let's say, for additional data XPath, it is interested to the client that what configuration exactly this particular X path belongs to. This is basically coming as a part of again engineering initiative that we have and learnings from that. For service assurance perspective, it is important to tie the configuration node with the operational node. And for non-NMDA implementation, it is not clear how that can be achieved by the vendors in a standardized manner. So that's the one item that we put together here from our service assurance learnings. Can I have next slide, please, Mahesh? So then we have the two RPCs. Get measurement metadata. So this is actually an important aspect. In a previous slide, I explained that we have a optimized measurement points, and we have a minimum observable period, and we had the suggested observable period. So they are the static data, right? So that's why the capabilities. But in many time, a client is interested in know this moment, what is exactly observable period that I must use on this path. So that's where this RPC has been defined. That for example, you will pass any X path, and the implementation needs to take that X path and figure it out. What is the optimal measurement point for this X path if a server supports this feature, because this is a if feature tagged item. If a server support the optimized measurement point feature, then it will compute the observable period that a client can subscribe to at that moment, right? So that's why computed, because it's done at real time dynamically and return the information back to the clients. So at that moment, client can subscribe using this computed observable period. In most scenarios, this will be greater than the minimum observable period that we have in the static list explained as a part of augmentation. Then we have active measurements. So this is an open item. What basically this active measurement is defining is we have more subscriptions on the router while we are computing the observable period for clients to subscribe to at real time. There are already multiple measurements happening on the router, so that information is also provided. It gives the client the flexibility to choose now whether they want to do what the device is recommending them, computed observable period at the real time, or they want to do their own optimization using the leaf list, which is basically provided as a part of the active measurements. Which has information about all active measurements happening for that path at that on the device. We have an also RPC called Get System Node Capabilities. So this is just to simplify the operation. Like we have the augmentation. If someone is interested in the node capabilities, you just pass a node and all of its subtree capabilities are returned. So this is also important for operationally, because IETF system capabilities model, which we augmented, doesn't have an flexibility to query the subtree, on the device if someone is interested only in subset of the capabilities. So this RPC will provide them benefit about that. So next slide, please, Benwa. These are the open issues that we have from early feedback that we did internally. Related note, like I said, it's for non-MDA implementations. If we can be split it into config node and state node. And then we also have, these examples we took care of, and it is there as a part of the draft, how the RFCs are used with different options. So expand on active measurement use case. So that's an open issue. So we have provided some examples so that we need to close on. We also have an open issues on whether the nanosecond is the right metric to use, or the microsecond is the one that we should aim for. So I'd like to thank you for giving me time. It was after 9. I really appreciate that giving me a spot and listening me here.
Thanks, Manish. So I think just quickly to close on this particular draft, I think as Robert mentioned, there is plenty of interest in the working group for work related to Node and Node capabilities, I think we probably need to form some team around it to see what are the problems that we want to try to solve in this working group.
Sure. I think one thing I want to highlight here is this optimized measurement point is also already implemented in some of our implementations. So it's not just an idea. So we have the implementation as well.
Okay. Kent, any final comments?
I have nothing more to add.
All right, that pretty much concludes this NetConf group session. Thank you.
Thank you, everybody.